Hi everybody, today I wanted to look at Fusion 360. This is a free CAD tool that you can use to generate 3D models and then run some simulations on them. In this case, the thing that we're going to be looking at is running a hydrostatic pressure test, which is, how well will the tank design hold up once it's filled with water. So you don't have to grossly over-engineer something necessarily, and you don't have to worry about flooding your house. Now, this is a program that is free for enthusiasts and hobbyists and small businesses that aren't doing CAD stuff. I've got the hobbyist license here. If you happen to be a student or something else, you can get a longer license for free. But the hobbyist license is easy to attain. I'll put a link down in the description below. Even if you don't want to do that, just a 30-day trial will work for what you're doing. So we're going to go ahead and mock up a quick test tank here. So to do this, we're going to need to make the actual model, but before we do that, we're going to have to make a material. We're going to go to model and we're going to go to simulation. Static test stress is what we're going to be doing. Okay. And under material, go to manage physical materials. Now the reason we have to do this is for plywood. Plywood is a complex material that this system just cannot handle for stress tests. There's too many variables in it, and we only really need a couple of them. So what we're going to be doing is going down to wood, going to plywood finish, and hitting this little up arrow with the pencil, and that'll give us a copy of the plywood finish here. Now when we look at the physical properties of this, you can see it has separate X, Y, and Z properties, and they're identical for everything except shear modulus. And the shear modulus is whether you're going against the layers or into the ends. And we're going to be doing into the layers, so this is the one that we want. So what we're going to have to do is we're going to have to make a material that has less properties so that this can actually work with it. To do that, the easiest thing to do, go to plastic, just pick something like the acrylic. Doesn't really matter what you pick. Ended up with acetyl resin accidentally. Doesn't matter. Acrylic clear. And you're going to rename this to whatever you're going to end up using. So we'll just call this one test. And what we're going to do is we're going to take the properties from the plywood and we're going to copy it over to our test material. So specific heat, just Control-C copy, over to test, specific heat, Control-V paste, move to the next line, apply. You're going to want to do this for every one of these entries. They're all the same in every entry except again for shear modulus, and in that case you want to use the 550. Now to save some time, I've already gone ahead and run one of these and named it plywood test, so I've already got that. Once you have that done, you're going to pop back up to the model layer. So we're going to go ahead and start constructing our tank. We're going to create a sketch, and we're going to put it on the floor plane here. We're going to make a rectangle, first corner in the middle, and then we're just going to type in the dimensions. So this one's going to be 96 inches wide and 48 inches long, or I'm sorry, 96 long and 48 wide. Scrolling in the program is the mouse wheel. If you click and hold the middle mouse wheel, you get the pan tool. Alright, so we've got our base. Now we need to make an actual base out of it. Normally when you do a plywood tank, you do doubled up plywood for the base. So we're going to go ahead and go to modify, press pull, and we're going to do a thickness that is 2 sheets of plywood. Now normally 3/4 inch plywood is actually 23/32, which is 0.71, so we're going to do 1.42. And that gives us, if we come up here to the home, a thick sheet for the bottom. I'm going to go ahead and do this again, sketch on the new top surface. And we're going to create a box that's the full width. Then we're going to shrink that box down by the width of plywood, so we have a single plywood thickness wall. Now that's a bad idea, but I'm going to do this just so I can show you how this program works and how we can modify it later. So you're going to right click anywhere, go to sketch, go to offset, and you're going to pick this box we just made, and we're going to move it in. Now, it's a good idea to move it manually by dragging so that you know if you need to put in a positive or negative number, because the program does randomly assign that. We're going to go ahead and do 0.71 for our plywood. And then once again, we're going to go to modify, press pull. I'm going to select this edge we just made, and let's make this tank 36 inches tall. That seems like a good number to me. Now at this point, we've got just a box. We need a window, or it's not going to do us any good. So we're going to make a new sketch on the front of the box. We are going to try to come up with a good size. So I like the idea of using a 24 by 72 inch window. That's a standard size of acrylic you can get. Now this is 96 inches wide, and we're not doing a uniform spacing, so I'm just going to separate this off a little bit. I'm just going to make a 12-inch box over here. "36 inches tall from 24, so we're going to do a 6-inch gap at the top. Then we're just going to drop in our window starting in this corner. Now we're doing the size of the acrylic, not the size of the hole. So we're going to do 24 by 72. That looks pretty centered. There's a little bit more of a gap on the bottom because of the 1.5-inch plywood, but I don't really want to factor that in. Now we're going to do the same trick we did earlier. I'm going to right click, sketch, offset, select this box we just made, and we're going to give this 1.5-inch lip that the window will actually be bonded to. So we're going to be working with this inside square here. Now, in order to cut, you go ahead and press pull. The shortcut key for that is Q. And you're just going to drag this the other way. It turns red, and the operation becomes a cut. Okay? And that'll give us a window. Now we need to make our acrylic sheet, so we're going to flip the box around using the rotate tool down here. Hit escape when you're done to get rid of the rotate tool, and we're going to make a new sketch on the inside wall. Now, because this box is in the way and we can't really see what we're doing, we're going to go to bodies. We're going to turn off body 1. Now, we've already got a selection here for where the hole is, and we know we need a window that's 1.5 inches bigger than that. So we're going to go ahead and go to sketch, offset. I'm going to click this hole that doesn't exist, and we're going to offset it by 1.5 inches, but now the numbers become negative. So negative 1.5, and that now gives us a 24 by 72 inch box. Now in order to work with this, we have to select this invisible section in here and start deleting the lines, or we're just going to get a border. And there are 4 of them. So just go through and remove them. And we're going to turn our body back on. We're going to go back up to a view back here. Now when we make the window, again you're going to press Q for press pull. Let's go ahead and make it 3/4 inch acrylic, so 0.75. And we want this to be a separate sheet or a separate unit than the rest of the body because it's a different kind of material. So under operation, we're going to change this to new body and hit OK. So there we have our basic box. We now need to assign the materials to this so that the program knows what to do with it. So right click on body 1, physical materials, and we're going to go to plastic, acrylic clear, and we're going to drag this to the window. The window becomes transparent. We're going to go up here to the library, go to favorites, and we're going to pick the material we just made, and we're going to drag it onto the box, so that the box now has the properties of plywood going through the plywood itself. So now we've got a plywood box and an acrylic window. We're going to go up to model, drop down to simulation, and we're going to start working on actually simulating some water pressure in this. So the next thing we're going to do is we need to add a fixed constraint so that the program knows where the base is and where everything else moves from. To do that, we're going to rotate down underneath it. I'm going to select the bottom, right-click, structural constraints, and OK. We're going to leave it as a fixed. The next thing we need to do to get this to work is to turn on gravity. So we're going to go to load case on the left. We're going to expand loads, and we're going to check gravity. If you don't do this, it will turn it on for you, but it will have a pop-up that comes up and annoys you with a little bong noise several times, which is a little bit infuriating in my opinion. So now we're going to actually set the water pressure. So we're going to right-click one of these inside walls, click, right-click, structural loads. I'm going to change the type to hydrostatic pressure. And then what we're going to do is we're just going to select all of the inside walls of the box and the inside of the acrylic sheet. Now, if you want to model a stand underneath this, you can. At that point, you'll want to put pressure on the bottom, but because I'm doing this as if it was just sitting on the ground, pressure on the bottom doesn't change anything. The next thing we're going to need is our actual water level. Where in the box is the water going to be? So we're going to go over here to select surface point, and we're going to select an inside edge. Then we're going to drop this down, let's say 4 inches. 4 inches from the top is a good number. That's it? Okay. Now we've got a basic simulation for water pressure set up. We can go ahead and try to solve it. Now, when we hit solve, it's going to give us an error. Or warning, I'm sorry. And this is because it doesn't know what to do with this window, which is a separate body, so we're going to go ahead and click automatic contacts. You'll also have this problem if you build a separate stand underneath. When you click that, it's going to say anything within 0.1 millimeters is counting as touching, which is fine. We can go ahead and do that. And we'll go up here to solve again. It's going to make us save the project. Well, solve. There we go. And I'm going to name this garbage because this is going to fail as far as what I'm considering to be okay. Now, this usually runs pretty quickly for simple stuff. It can take forever on more complicated things. The more supports and things you put in, the more complicated the actual solutions are. So this one I'm going to go ahead and let through. Once we make the modifications to the tank, I'm going to end up cutting that later. But when you hit solve, it will, on the free accounts, upload to their servers. It'll solve it on their end. It'll re-download it. It has a local solve option, but it doesn't seem to work very well, and I don't really know why. You know, my main editing system is a really beefy system. I've got 32 cores in it, I've got 128 gigs of memory, and it still just panics and craps its pants and doesn't tell me why. So I just use the OnCloud. It is free for the free account, so it doesn't matter. Okay, so this runs through, and we see this particular tank has a minimum safety factor of 3.4. This is not good enough. If this were a full accurate simulation, 3.14 or 3.41 would be fine, but because plywood has some weakness, it has some bubbles in it, because all of this is really being held together with glue and screws, 3.14 means you're probably going to have a failure point in this someplace, especially maybe on these corners here. So you can see the base down here where the wall connects. There's a lot of pressure. The corners, there's a lot of pressure. And down in front of the glass, there's a whole lot of pressure. There's also a spot up here at the top where there's a chance that you'll just end up with the supports breaking because of the bowing that the wood will do. So we want to fix this up. This is something that I consider a bad build. In my opinion, with this program, because of the irregularities in plywood, because of the flaws and things that can exist naturally in the material, we want a minimum safety factor of at least 9. Now, that's not showing on this list here because it's 3.41. It goes up to 15. Anything higher than that, it doesn't bother to study. So we're going to pop back to the model, and we're going to go ahead and make some quick modifications to this. The first one we're going to do is just put in a base plate all the way around that will give us some better support on the bottom of the tank. So I'm going to go ahead and create a sketch on that inside wall. I'm going to hide the body. I'm going to go ahead and make some 2x4s down here. Now, 2x4s, also one of those things that lies about the size. So we're 3.5 inches tall, 1.5 inches wide. Go ahead and make another one on the other side. On the top, I'm going to go ahead and add some plywood supports. I'm going to make these 0.71 inches deep, and let's make them 8 inches wide. About. Put our body back on. Next thing we're going to do is we're going to add some top support braces on the side, in the middle, and on the side over here. We're going to create a sketch on the inside edge of this. Again, hide the body. Do one on each side. And then for the middle one, I don't feel like measuring this out, so what I'm going to do is I'm going to go roughly where I think the middle should be, and you can see this triangle here, and this is the actual center point. So now I can just do 4 inches either side of this. And that gives me an 8-inch piece in the middle. Turn that on. Oh. Yep. Sorry. We need to know how long it is, so inspect. Inside edge, 30.58. .58. Again, make sure join. Done. So now we've got a solid top support. We need supports on each edge on the bottom so we can complete the box. We're going to make a sketch here. Hide the body. Five. 0.5. Go ahead and find out how long it is. Looking at 43.58. Obviously, if you're making this out of real wood, you're not going to have that level of precision going on, but you have to do it for this program. Then let's go ahead and run up some supports in the corners and one in the middle. That didn't go all the way back. Now it does generally snap to the corner, but again, it sometimes just sort of does what it feels like. This is probably the most infuriating program to work with that I do, but it is the easiest for running these kinds of simulations, so a little bit more forgiving with it than I otherwise would be. We want the midpoint. Should be, yep, there we go. I'm going to do 1.75, 5. Same thing in the other direction. Then we want a couple of supports up here in the top corner. I'm sorry, front corner. Okay. Then all of these should be pulled out to the same length. So we just need one measurement. 31.79. Okay, so now we've got supports on all sides of the box on the inside, so the outside looks nice and clean. Come back to simulation, and we've got an error. Now, this error is because when we added these top supports, you can see in the old model that's still here, there were no top supports. When we added the top supports, it moved our surface point. So our surface point for the water no longer exists. So we need to come in here and try to set a new one up. You want to make sure that you get the inside edge of this if you can. You just kind of have to move it until it clicks to where you want it. And we're also going to add these pieces of wood to the water pressure faces so that they get interacted with correctly. And we split the back face into two, so we have to reselect the right side. Why did it ding? Your guess is honestly as good as mine. And then we don't need to do those because those are pressing into the wood, but we do need to do the front face on this one. Okay, that's it. Now we've got 16 faces, our water pressure is set again. We can rerun the solution using the new supports that are added. Remember with all of these things that anytime you add supports, it's going to basically be screws and glue holding it together. So make sure you add more than you think you need. Doing some fiberglass around the outside edges to hold everything together is generally a good idea. Don't expect your corners to be what this thing says. Let's go ahead and run a quick solve on this and we'll see what kinds of improvements we made. This one's going to take a while, so I'm just going to cut here and come back when it's done. And we're done. You can see we've bumped our minimum safety factor up to 11, which is well within the range of safe to work with stuff. Now, this box still looks pretty bulgy. It looks like there's still a whole lot of bulge in the window, a whole lot on the sides, a whole lot of the frame. So I want to show you what this actually relates to using some of the tanks that I've already made. I'll go ahead and load up my grow out tank here. Okay, so you can see here, this is one that I've already run calculations on. And you can see the windows on this look like friggin' eyeballs. The top has a fair amount of warping on it. The rest of the box doesn't have any sort of warping that's visible at all. This one is 3/4 inch plywood with additional 3/4 inch support around the outside here, along the entire front face, and then a 3/4 inch bar down the middle separating it out so that I can keep different batches of fish separate. And I just have a siphon running over this to connect the water so that I can do constant drip water changes. I'm going to go ahead and put up some footage of the actual tank here. You can see, comparing this to the model, that there's basically no bulge in anything. Now, there is some lensing in the windows. If you get within an inch or two of the windows and kind of look to the side, it's a little bit distorted. It can kind of give you a headache, but as long as you're more than 9 inches away from the tank, you don't see anything. Now, my pairing tank is the one that I have a lot of my more recent videos in. You can see here, the entire box looks like it's bulged out. Not just the windows, but the frame, the plywood, the top supports, everything. And you can see here in the actual pictures that there's nothing at all, the slightest bit bent anywhere. Again, there's a little bit of lensing in the picture, or in the window itself, but it's not bad. This one has an odd spot on the model where it has decided that this little tiny section on the inside edge of the window is not quite good enough to be considered what I like, but I genuinely think that's a fluke of the calculations and not an actual problem with the tank. I do keep the water a little bit lower than I had in this calculation, so that's probably fine. My Water Dragon tank is the one that I mentioned in my epoxy video, that before I added top supports it just splayed out horribly. This is with the top supports. It was completely rigid with that. You can see this in some of my earlier videos. I've since gotten rid of it. You can see again the eyeball effect of the acrylic. This uses 0.22 inch acrylic. It's less than 1/4 inch. The windows were 16 inches tall by 22 inches wide, and the 0.22 inch acrylic worked fine for that. There was, again, a noticeable lensing if you're close, but genuinely I think you're going to get that no matter how thick you go, unless you're going to 2 or 3 inches thick. Now, the last one I want to do is the 2,300 gallon tank that I'm working on. This one, you can see there's some major lensing going on in the windows. Again, looks like eyeballs, but there is nothing on this one that is below a minimum safety factor of 15, so even though there's going to be probably a fair amount of lensing going on in the acrylic, it should all hold up without any issues. There shouldn't be any breaking or tearing or anything else going on in this. So this is a tool that I found indispensable in designs more than anything because it gives me a good idea of where the pressure is going to be and where I need to be adding some additional supports. So this one here had all sorts of failures, and the way I got around that was adding 4x4s every 24 inches on the inside supports, adding another 4x4 around the rim in here, another one around the rim in the base, and that was enough. Now this thing is just a rock-solid box, nothing's going to happen to it, and that's the spacing that I was going to be using for the windows anyways, because this way I can use the cheaper $30 each windows instead of having to go with larger windows that are going to run me about $400 each. It's a useful program. Hopefully it's something that you guys will be able to use, even if it's just for a one-off project. It's pretty simple to use once you get used to what you're doing. I've laid out everything you need to know to be able to put in the stand here, to be able to use glass. You just choose a different material. So, I hope this video is something that you'll find useful, and we'll catch everybody next time.